Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. This is factor and solve when a does not equal 0. This is going to be the next level of factoring and solving. This is the next step after the last two sections we have done. Okay, there are going to be 4 steps that we will talk about as we kind of work through some of these problems, but I'm going to add one extra step, and that is always the first thing we should look for is a GCF. If you have a GCF, you need to always pull that GCF out. That is the easiest and best way to work through the problems. Okay. Now, on to the other 4 steps. The first step is going to be to list our factors for A and C. In our last couple of sections, we've only had to list the factors for C because A has always been 1, so it's always just been 1 times 1. So let's go ahead and look at example number 1 to see how that works. I'm going to go ahead and list my factors of 2. That would be 2 times 1. And list my factors of 3. That would be 3 times 1. Now, from here, I need to find some combination of these numbers, or I need to choose the pair of factors that will add or subtract to find my B value. All right. So what I'm trying to add to here is positive 7. So I need to find some combination of multiplying the numbers from this side with the numbers from that side that will add to my B value, which is positive 7. So the first thing I'm going to try to do is take my 2 and multiply it by 3. That would get me 6. If I multiply 1 by 1, that would get me 1. Well, 6 plus 1 does in fact equal 7. So that is the combination of factors that I need to use. The next step is going to be to make our parentheses. Okay? We want to make our parentheses. So we're going to write as parenthesis. My 2 and my 1 from the beginning here, from this side, are going to go in the front of my parentheses. So I'm going to go ahead and write 2x and x, because 2x times x would get me my 2x squared. All right. Now I'm going to come back over here and see what I multiplied each number by that ended up adding to positive 7. So I multiplied my 2, or my 2x, by 3, right? So I'm going to put that back here. Because when we do double distribution, I multiply the beginning times the end. All right. Now, this is 1x, so I need to multiply that by, or put the other 1 in this location, because I would multiply this and that together to find my B value. Remember from our previous lesson that if both signs are positive, then both signs in my factored piece are also going to be positive. The last step, that leads us to the last step, is to make the bigger factor the same sign as my B value. Well, the sign for my B value in problem number 1 is positive, correct? My big factor is going to be this 2x times this 3. Well, 2x times 3x needs to be positive. In this case, they're both going to be positive because both of the signs in my first problem were in fact positive. All right. All right, on to number 2. The first step is to look and see if we have a GCF. Well, I have 6, 21, and 8. Are those all divisible by the same number? They are all divisible by 3. So my GCF in this case is going to be 3. So if I take out a 3, 6 divided by 3 is going to get me 2x squared. Negative 21 divided by 3 will get me negative 7x. 18 divided by 3 would get me positive 6. From here, I'm just going to work through my next 4 steps. But the first thing I want to look at is when this is factored out. When I have it down to that look, okay? From our previous lessons, if my back sign is positive, then both the signs in my parentheses will be the front sign. So in this case, both these signs need to be negative. All right? So that means whenever I find what I need to multiply together, it's always going to come out negative. So now let's just go ahead and start with step 1, which is to list my factors. It'd be 2 times 1. 6 is 6 times 1, and 2 times 3. If I try to combine 2 times 1 and 6 times 1, I could try 2 times 6, which is 12. 1 times 1, which is 1. Would negative 12 and negative 1 get me to negative 7? No, it will not. How about, so this won't work. How about 2 times 1, which is 2, and 6 times 1, which is 6? Would negative 6 and negative 2 get me to negative 7? They will not. So now I can try 2 times 2 and 2 times 3, or the 2 times 1. So I'm moving on here, I'm sorry. I'm going to get rid of my choice of 6 times 1 from my C value. So now I'm going to try the 2 times 1 and the 2 times 3, some combination of those. Well, 2 times 2 would equal 4. Remember, these are all going to be negative. 1 times 3 would equal 3. Would negative 4 and negative 3 get me to negative 7? Yes, it will. So I'm going to go ahead and put these, the 2 and the 1, just into their own place here. I can put them wherever I want at this point because both my signs are negative. Now, what did I multiply my 2 by? I multiplied it by 2, so I need to put that in the back side. What did I multiply my 1 by? That was by 3, so I'm going to put that in the front side. And do not forget about your GCF, which was 3. And that is what my problem will be once it is completely factored out. It would be 3 times 2x minus 3 times x minus 2. All right, moving on to problem number 3. Here I have 2x squared minus x minus 3. In this case, from our previous unit, we know that because the back sign is negative, that the signs in my parentheses will be positive and negative. I don't know what I'm going to put where yet, but I do know that I'm going to have a positive sign and a negative sign inside my parentheses. So here we're going to start with our first step. Actually, our first step is to see if there's a GCF. Well, I have 2, 1, and 3. They're not all divisible by the same thing, so I do not have a GCF here. So I'm going to find the factors of 2 and the factors of 3. I need to find some combination of these factors that will get me to negative 1. I want my larger factor to end up being my negative, okay? So if I try 2 times 3, that would be 6. So we would think that this is negative 6 is what we want. 1 times 1 would be 1. Would negative 6 plus 1 get me to negative 1? No, it will not, so this will not work. Now I can try 2 times 1, which is 2, and 3 times 1, which is 3. Which of those two is larger? Well, it would be the 3. So does negative 3 plus 2 get me to my negative 1? It does. So what I want to do now is make sure that the 3 from this back end is what ends up being negative. So I'm going to go ahead and put 3 in this location. What did I multiply 3 by? I multiplied it by 1. So that means that my front side is going to be x, which leaves me with just my 2. So 2x will go here. And what's left is that 1. And that is the factored form of problem number 3. On to problem number 4. I have 3, 16, and 5. 3, 16, and 5. The first step is always to see if I have a GCF. Well, 3, 16, and 5, none of them are divisible by the same number, so that will not work. What I need to do now is to get my factors of 3 and my factors of 5. I need to list that. Remember that we want to go ahead, at some point, we're going to make parentheses, correct? Both of my signs here are positive, which means that both of my signs here are going to be positive. Because that is the case and my signs are the same inside of my parentheses, it does not matter where I put my 3x and my x. It does, in fact, on the other hand, matter what I multiply my 3 by and what I multiply my x by, my 3x by and my x by. Okay? So I need to have some combination of 3 times 1 and 5 times 1 that will get me to positive 16. If I try 3 times 5, that would get me positive 15. 1 times 1 would get me positive 1. Does 15 and 1 add to 16? Yes, it does. So here's where we need to be careful. I need to multiply my 3x by 5. Remember, it's the outers are going to multiply together and the inners are going to multiply together. So it would be 3x times 5, 1 times 1, and there is my factored form of number 4. The next section is to factor and then solve. So I need to factor, and then I'm going to use the zero product property to solve for my x values. Again, it is exactly the same steps that we used on every other problem so far. We're going to see if there's a GCF. Then we're going to list our factors. Then we're going to make our parentheses and put our signs in our parentheses. Then we need to find some combination of our factors that will add to my b value or subtract to my b value. The first step is to see if I have a GCF. Well, 4 and 8 are both divisible by 4, but 3 is not divisible by 4 or 2, so I will not have a GCF here. I'm going to go ahead and list my factors of 4. It'd be 4 times 1 and 2 times 2. I'm going to list my factors of 3, 3 times 1. I need to find some combination of these numbers that will add to positive 8. I'm going to go ahead and make my sets of parentheses and put my signs in place. Since both of my signs are positive, both of the signs inside of my parentheses will also be positive. Okay? I'm going to go ahead and try to erase that there. So now I can go ahead and try 4 times 3, which would be 12. 1 times 1, which would be 1. Is there any combination of 12 and 1 that could ever get me to 8? There is not, so that will not work. Now I can try 4 times 1, which is 4, and 3 times 1, which is 3. Will any combination of 4 and 3 ever get me to 8? Again, no, it will not. So our 4 and 1 will not work. Let's see if the 2 times 2 and the 3 times 1 can get me to positive 8. Well, 2 times 3 is 6. 2 times 1 is 1. Or I'm sorry, is 2. I apologize. 6 plus 2 will in fact get me to positive 8. So I know that my combination has to be 2 and 2 and 3 and 1. Being that the 2 and 2 come from my 4x squared, this would be 2x. This would be 2x. My 3 and 1 come from my 3. They need to go in the back side of everything here. Well, since these are both 2x, it does not matter where I put the 3 and the 1. Remember that this is going to be equal to 0. Now I need to use the zero product property, which means that I can just take each of my parentheses and set them equal to 0 individually. I would subtract 3. That would leave me with 2x is equal to negative 3. Divide by 2, divide by 2. So x would equal negative 3 over 2. I need to subtract 1 here. So 2x would equal negative 1. Divide by 2, divide by 2. So x would equal negative 1 over 2. And those are my two answers. All right. So now we're actually solving for x. All right. Let's move on to number 6. Is there a GCF here? Well, I have a 2, a 1, and a 15. 15 is not divisible by 2, and 1 is not divisible by 2, so there is no GCF. I'm going to go ahead and make my lists. This will be 1 and 15, and 3 and 5. All right. I want to go ahead and make my parentheses. Since my C value is negative, I know that 1 is positive and 1 is negative, correct? Now, I need something that's going to add to positive 1 for me. Is there any way that 2 times 1 and 1 times 15 could ever get me to positive 1? Well, let's go ahead and just try it. 2 times 15 would be 30. 1 times 1 would be 1. There's no way that 30 and 1 could ever get me there, so those won't work. 2 times 1 is 2. 1 times 15 is 15. There's no way that 2 and 15 could ever get me there. So 1 and 15 will not work. Let's try 2 times 1 and 3 times 5. If I do 2 times 3, which is 6, and 1 times 5, which is 5. Is there any combination of 6 and 5 that could get me to positive 1? There is. If my 6 is positive and my 5 is negative, then that combination could get me to positive 1. So what I'm going to do is I need to make sure that my 6 is going to be positive. So my 3 is going to have to go where my would allow me to make my 6 positive. My 2x then would have to go on the inside as well. My 1 would go on the outside, my 1x I should say, and my 5 is now negative. All that will be equal to 0. Now I can use zero product property. Subtract 3, x would equal negative 3. Add 5, 2x would equal 5. I need to divide by 2, x would equal 5 over 2. So I am good. All right. Moving on to number 7. The first thing that we need to look at here is, are we set equal to 0? Is it in standard form? Here it is not, so I need to subtract my 6 to bring it over, just like we did in our graphing. This would leave me with 3x squared plus 17x minus 6 would be equal to 0. All right. Now that it's equal to 0, I can go ahead and try to factor this. I'm going to look for a GCF. Well, 17 is not divisible by anything but 1, so there will be no GCF here. I would have 3 times 1 for my list, 6 times 1, and 2 times 3. I'm going to go ahead and make my parentheses. Since my C value is negative, I know 1's positive and 1's negative. Now, we need to start thinking here. I need to get to a positive 17. Is there any way that 3 times 3 and 1 times 2, or 3 times 2 and 1 times 3 could ever get me anywhere near 17? There is not. So I'm pretty sure that that 2 and 3 will not work for me. So what I'm going to do is I'm going to take 3 times 6, which is 18. 1 times 1, which is 1. Is there any combination of 18 and 1 that can get me to 17? There is. If my 18 is positive and my 1 is negative, then I can get to positive 17. So I need to make sure that my 6 from here is going to be positive. Put it there. That means my 3x needs to go with it, because that's what I multiplied by to find my 18. Here, my 1 would be there, and my 1x would go there. All of this is set equal to 0. From here, I can go ahead and split them up using the zero product property. I can subtract 6. X would equal negative 6. I can add 1. 3x would equal 1. Divide that by 3. And x would equal 1 over 3. And I am done. On to number 8. Again, here I am not set equal to 0, so I need to add my 5x in order to set it equal to 0. Because I'm adding 5x, and I want to write this in standard form, I need to write it in descending order of my powers. So I'll have 20x squared first, plus 5x, minus 15 is equal to 0. As you notice, I have x squared, and then I have x to the first, and then I do not have an x. That is what I mean by descending powers. All right. What I'm going to do now is look for a GCF. Is 20, 5, and 15 divisible by the same thing? They are. They're all divisible by 5. So if I pull a 5 out, what's 20 divided by 5? That is 4x squared. 5 divided by 5 would just be 1x, and 15 divided by 5 would be a negative 3. So I do have a GCF on this problem. After I've looked for my GCF, I'm going to make my lists. So 4 times 1, 2 times 2. I'm going to have 3 times 1, right? From there, I have set up my parentheses every time. Do not forget about your GCF of 5 out front. Since my C value is negative, I need to have a positive and a negative. I need to find something here, some combination of all of my factors that will allow me to get to positive 1. Let me try 4 times 1 and 3 times 1. Well, if I do 4 times 3, that would equal 12. 1 times 1 would equal 1. Is there any way that 12 and 1 would ever get me to positive 1? There is not. So I'm going to go ahead and try 4 times 1, 4 being from here, 1 being from there. That would get me 4. Then I can try 1 and 3. So 1 times 3 would get me to 3. Is there any combination of 4 and 3 where one of them is positive and one of them is negative that could get me to positive 1? There is, if my 4 was positive and my 3 was negative. So again, I need to be careful here. Because it's 4 times 1, I need to make sure that my 1 is positive, which means my 4x would go in the inside. Then I'd have x on the outside because I had 1 times 3. Those will go on the outside. From here, I need to set everything equal to 0. So 5 would equal 0, x plus 1 would equal 0, and 4x minus 3 would equal 0. That is my zero product property. Now, does 5 equal 0? No, so I can really just cross that out. But you do need to write that down and cross it out for me to understand that you did use the zero product property correctly. From here, I'm going to subtract 1, so x would equal negative 1. I'm going to add 3. 4x will equal 3. Divide that by 4. Uh-oh. My smartboard messed up there. Divide by 4. Divide by 4. So x would equal 3 over 4. And those are my 2 answers. So that is the end of our lesson. The most important things here are to know your 4 steps, plus you're always looking for your GCF at the beginning. You're going to list your factors in pairs for both A and C. You're going to choose a pair of factors that will add or subtract to get us B. We want to make the bigger factor the same sign as B and then determine the sign of the other. And then we need to write our equation in 2 sets of parentheses. Thank you very much for watching this video. Remember, if you have any questions, to ask me tomorrow, and have a great day.